Hello everyone, welcome to another video, and this video is using route tagging to prevent routing loops. This is a really big lab, which is my CCIE version. Here it's a CCIE lab, but it is a CCIE redistribution lab, and then we're going to be using route tagging to prevent route loops and suboptimal paths. So I know it is a big network, but our main thing is the reason I have created this topology is to have a multiple route redistribution, multi-point route redistribution, so we can see if we have a routing loop, and also we will learn how to prevent it. For example, now we have three points of redistribution today. We have a R4 which is running RIB and EIGRB, and it is redistributing both of these into each other. And we have R3 which is running RIB and OSPF, and at the same time it is redistributing these two routers into each other. And also we have R6 which is running OSPF and EIGRP, and it is redistributing into each other. For example, if we go now to R3, so we say show run section router, then I'm going to prove you that it is running RIB and OSPF. It is running OSPF and it is running RIB. And if I go to R4 and prove for you section router, then we will see it is running EIGRB and OSPF. It is running EIGRB and router and RIB. It's R4 is running EIGRB and RIB, and R6 show run section router. Then this one is running EIGRB and OSPF at the same time. Perfect. So now we're gonna start redistribution without further delay. Let me go to R3, start from R3, and then now this time we know how to redistribute. So we go to router OSPF 1, and then we're gonna redistribute RIB into EIGRB, RIB subnets. So that key subnets must be there at all the time if you are not running version 15. If you are running iOS version 15, then it is gonna add immediately, automatically after this. And the metric type of OSPF, because as I said before, every routing protocol has a certain characteristics. So OSPF has a characteristics. So any routing that is coming into OSPF, they will need to have OSPF characteristics. For example, because they are going to P, OSPF will be populating this network into another area. So there will be an OSPF OSPF will be responsible for reachability of these networks. So now we have OSPF. So the characteristics of OSPF, the RIB routers must take the characteristics of the OSPF, for example, like a metric type and the metric. So metric is the OSPF has a metric of 20 by default. So if I change it now to any number here, these numbers will show up, and I hope that you have caught this up in the previous lectures. And the metric type, as we said, the OSPF has a type 2 and type 3. So type 2 has the default of 20, and type 1 it just accumulates the as we have seen before, it accumulates the linkage paths, the linkage costs. So it just adds up the linkage cost. So now I will just say like metric type, I don't need it actually because the default is 20. So now I redistribute it, and then I will go to now I redistribute it into OSPF because we say router OSPF, and then we redistributed our RIB OSPF, and then we added the key subnets. Then I was going to issue metric, so I just put it ME, but that's not the case, so you don't need it. So that I mean, we redistribute it. So now we're gonna go, okay, we are going to go to router rib, and then we are going to redistribute OSPF rib, OSPF into rib, and you know rib has a hop count, so we will be seeing the hop count. So redistribute rib, and then redistribute OSPF, and then OSPF number, because if you give a question mark, it will ask you the OSPF process. So we're gonna give it 1. The 1 is the one we are using across, and you can use any number, and then it will ask you the metric. It will ask you the metric. So if I say metric, then it will ask you, it will show me the hop, OSPF hop count. It was 0 to 60. So I'm going to give this one, as usual, 11. So at this point, we have done redistribution on R3. So if I say show run section router, I will show you what I have configured here. I went to OSPF, and then I redistributed rib routers into OSPF, and the key where subnets I've added. And because if you don't add key subnets, then it will redistribute only the major network, so it will not redistribute any subnet networks. So now, if you are running 12.4, as I said, 12.4, you need to add these manually, subnets. But in our iOS 15 code, it doesn't need, because it will add it for you automatically. Okay, I went to router rib, and then I redistributed OSPF routers into rib, and I give the hop counts of these are OSPF routers. Yeah, they are becoming a rib routers, so they need to know the metric of rib. So I just gave them 11. And now if I go to, for example, now I've done mutual redistribution on this guy. Mutual means I have allowed my OSPF routers to go into rib, and I have allowed rib routers to go into OSPF. So if I go now R15, which is the further corner, I will see the external routers of rib, like 10.1.1.1, because R1, R2, R3, and R4, they all running rib, but R4 is running additional EIGRB on for this segment. But from here, start from this link all the way to this link, and here all the way to here, they are running rib. So if I go to R15 now, for example, I will see all these routes, and 10.1.4 routes, they are all running rib, and 34 as well, and also 192.1.23.0, they all be in R15 routine table. So if I show IP route, let me make it a little bit bigger. IP route OSPF, then you see we have all the routes, all the external routes. You have, let me show you here. You have network 1. Where is a network 10? You will have a network 10, because we have to give it a little bit time. Okay, now we have 34 network, which was rib, and we have 192.1.23, which is rib, because now they show us a E2, and that is this network right here. And then we have 200 routers. I think these 200 routers are running into R2, R1 as well. And what else? What else? And I don't think I've run this, advertised this. So show run EIGRB router. I don't know what I have run. Okay, I have something, so let me no router rib, and then I'm gonna get this, and then I am going to get these networks, and yep, okay, so R15 sees all these networks now, but these networks, did I no auto summary under version 2? So I think we just gonna give it a little bit, do clear IP route, because rib is just, so what I want to these networks, I think network 11 we have seen, but these two networks to make it into R15. That's my whole idea, because we already network 11 or these two networks, network 11 always, no, that is another network 11. So clear IP route. So now we have done in R3, isn't it? So now we see this network. So this part of networks, I think in the GNS3 just kind of like slow, but we can see this network. We don't see any 10 networks, but what we see is let me check if I have 10 network in this guy. This is connected to 10. Okay. Got 33, it has it, 34, 192, yeah. Okay, what about R2? Because so let me go back to R2, no router rib, then I'm gonna reconfigure it. I just want to make sure the GNS3 has some bugs sometimes, so I just want to get rid of it. No auto. So if I go to R3 now, I should see this route is right here, since I advertised on R1 at 10.0.0. So R3 now, show IP route rib. It has a 10.1, it has a 10.1.2, which is this guy right here, and it has a 10.2.1, another that's for R2, and then all this. Okay, let me go to R15 if this route is make it now. Yeah, now you see these routes they have made into a routing table. So sorry guys, I was just making sure that we have reachability on this one. So I want to end to end from 15 reachability from ping from 15. I want to go all the way here to R1. So now let me ping, since now only R2 is doing the redistribution, yeah, rib into OSPF and OSPF into rib. So let me say 10.1.1.1.1, and now as you can see we have a reachability success from R15, which is here, to R1. Perfect. Now let me go to R4 and do the redistribution. Router EIGRB1. Now redistribute rib, and then the metric of EIGRB, because this EIGRB rib routers will take the metric of EIGRB. So now the metric will be bandwidth. I'll just did one as I said before, and then I will make one, all of one, loading, bandwidth, all the things, like for example bandwidth 1, loading and delay 1. I just made, it doesn't matter, just I'm doing a 1, I'm just giving 1, but it does not matter, it doesn't cause any problem. It just needs to specify the metric of the routing protocol that you are, the routes that you are redistributing into the another routing protocol. It needs the redistributed routes needs to have the metric of the protocol that you are going into, that you are redistributing into. Does that make sense? The redistributed network, which is RIP routers in this case, need to have the metric of the protocol that you are going into, you are redistributing into, and in this case it is EIGRB. EIGRB has a composite metric, which is bandwidth, delay, loading, and reliability, and MTU. So now we are done here, and let me go to RIP as well. So EIGRB router, EIGRB and EIGRB routers will have now we're gonna redistribute EIGRB, and then the autonomous system is 1. Then we're gonna redistribute into RIP, and then the metric. So now the metric will be the hop count of RIP, because now we are under RIP and we are redistributing our EIGRB routers into RIP. EIGRB routers into RIP. So the EIGRB routers must have the metric of RIP, which is the hop count. So I'm going to give it 11 the same. So enter. So now we have done the redistribution on this guy as well. So show run router. So we went to under EIGRB, and then we redistributed RIP routers into OSP into EIGRB. And we went to router RIP, and we redistributed EIGRB routers into RIP. We redistributed EIGRB routers into RIP. And we went to EIGRB, and we redistributed RIP routers into EIGRB. Done. Okay, so let me go to R6 and finally conclude this router EIG and OSPF, because let's go to on R6 it's running EIGRB and OSPF. So go router EIGRB, and then we redistribute OSPF routes into EIGRB. We are redistributing OSPF routers into EIGRB. So now they're gonna have the metric, and the metric will be same 1. I'm gonna make it 1 dot. I'm gonna make it 1 for bandwidth, 1 for reliability, and 1 for reliability, 1 for bandwidth, 1 for delay, 1 for reliability, 1 for loading, and 1 for MTU. And 1 for MTU. As you can see, EIGRB delay I did 1, EIGRB bandwidth I gave 1, EIGRB delay I gave 1. EIGRB bandwidth I gave 1, EIGRB delay I gave 1, EIGRB reliability I gave 1. EIGRB loading I gave 1, and the last one EIGRB MTU I gave the last one. So enter. So now we're gonna go to router OSPF 1, redistribute. Then we're gonna redistribute EIGRB routes into OSPF. Redistribute EIGRB. Then EIGRB will have the subnet keyword of EIGRB 1 autonomous sister, and it will have a subnet. So now we have done this one as well. So if we go show run section router, we went to EIGRB, and we redistributed OSPF routers into EIGRB, and they took in the metric of EIGRB. And we went to the router EIGRB, and we redistributed EIGRB, and then autonomous system and then it took the keyword subnet which OSPF must have. Okay, now I'm here. If I want to ping network 10.1.1, let me just clear IB route star, and then I go to R1 just for the sake, clear IP route star, then I go to R3, clear IP route star, and I'm making short like clear as CLE, but clear is just a clear like that. And then let me go to R4 and the clear IP route star. So now let me go to R6 if I can ping. If I can ping 10.1.1, so I can ping successfully. If I go translate to so now it's okay. R6 is okay. If I go to R3, ping 10.1.1. is going okay. If I go to R15, same before, it is going. So if I go to R1 and I ping 6.6.6.6, so the trace route 6.6.6.6. Okay, perfect. We should have a loop in this network, but now it's not showing as it have a loop on this network. Okay, so what we're gonna do, we're gonna save it, or we're gonna distribute, and then I'm gonna turn them off and then turn them back on, so we can see if we have a loop, because sometimes, and then let's go back on. Sometimes what they do, they just don't catch up. So give me a moment. We're gonna do it just right before you everything. Okay. I think route is also not coming yet, because they just the routers are not coming yet because the router is just started routing. So now advertising might come. IP, OSPF neighbors. Yeah, let it establish the full relationship. Now the neighborship come up. Now the redistribution is there. Redistribution is there. Everything is there. But why is not pinging? Because R1 should advertise now. Show run. Router R1 should be advertising these networks now. Yeah, 10 is not working. And R3, R2 at the same time it should advertise. It is advertising. Let me take this network off. So now R3, it has a 10 networks. It cannot ping. Let us trace route. Exactly, this is what I needed you guys to show. This is what I needed you guys to show. Can you see that? We have a loop in the network. That is what I want you guys to show. And that's what we're gonna prevent it today. Prevent the route loop. There's a loop in the network. So now, no one before they used to. So the GNS3 sometimes, you know, it just doesn't take it, so it's a virtual. So now I turn it off and I turn it back on. So this guy, he cannot have it. If I go to R1 and I trace 6.6.6.6, then it's not going to even reach anything. It's not going to go anywhere. The reason why, because we have loop. So now R6, if we say trace again, that was R3 that we traced. There is a loop, you see. So what is the loop? Where the loop is occurring? The loop is occurring between, look, the loop is occurring between, okay, let it finish. That's it, because 30, so the loop is occurring between R46.6, which is right here from here, and then it's coming back 67 to 7. It's coming here. It is coming, let it go, let me show you where it's coming. When they started the loop. So we pinged from R6, yeah. So now it went through 67, from 67 to 7. So that means that instead of ping, if going this way, it went through here, and then it went to 37 to 7, and it went through here. So it came out of here, it went up to here, and then it went to R4, and then instead of going that way, it just went here, and then it just went back to R6. It just took this way right here, and then it went back to here. So basically it's just this is what it's doing. That is, you know, this is just plain in here, so no one can reach it. So if you go to R15, I say trace route 10.1.1.1, which R1. Now look, now it's going to go all the way from 45, and then it's going to be plain in, let it finish. So when finish, I'll show you. Now I went to R5, R15. Yeah. Now I went to R15. So the network came from R15. The network came from R15 to 134, which is right here, 134. And then it came to R8 to R3. So it came through from R8 to R3, which is 35, which is 38.3. They're right here. And this interface, 38.3. 38.3, and then 38.3, and then it went back to R4. It went to R4. So when it came here, it just went out to here, straight to R4, and then it went to R6, 46.6, and then it went to R7, and it just went from R6 to R7, and went back to R3, which is 37.3, and then went back to R4. So basically the route made it here, all the way here, and then it went all the way, the route made it all the way here, and then it went here, and then it came back here, and then went here, and came back here, went back there. The reason why, because the administrative distance is gone. So the routes, they don't know where they are going and where they are coming. I mean, it's just a mess. So how can you deal with it? The way we can deal with it, let me prevent it that. So what can I do now? What we're gonna do now, we're gonna make a route map, and that route map, I'm gonna give it a tag number, identification number of every routing protocol, and then I will be denying data based on that tag. I will be denying when the route, for example, when the OSPF route is, I will not allow them to go back in to R8 or to go back in. Now, in this case, they are going back into R7 and R6. So I will not allow OSPF routes to come back to go to R to come back to OSPF route. OSPF, when the route is coming out of OSPF, I will not let them go back to OSPF again. And the route is coming from EIGRP, I will not let them back to come to EIGRP, because it's going to create a loop. So how can we do that? What I can do, I will go to R5 and I will just R3 and just create a loop back, route map, and that route map, R3, what is it running? R3 is running, let me go. R3, where is my R3? R3 is running OSPF and RIP. You see, OSPF and RIP. And this one, I will just call it RIP 2. I will make it RIP. I'll just use that arrow. RIP 2 OSPF. Enter, because it is running RIP and OSPF. So this one will be for RIP routes. And then I will give the set. I'll give just the tag. Set tag, and then since these are RIP routes, I will just always RIP has administrative distance of 1. Let me go and go to R2 itself. Set tag 1. If I go show IP route RIP, yeah, I gave, but normally I gave 1 to 1. Yeah, it has a 120. The administrative distance of every router of running RIP will be RIP administrative distance is 120. So now in here I'm gonna reflect on here, and I said route map, and then I just gave tag identification number RIP 120. So now that 120 will appear any OSPF route, any OSPF area, because OSPF will see these routes, will know that these routes they came from are RIP routes. So OSPF will not allow those RIP routes to come back into RIP again. So based on that tag, we're gonna filter. So let me. So I've just done that, and then I'm gonna create another route map, and that route map, another route map, and that route map I will say OSPF to RIP. I'm still on R2, on R3. I'm still on R3 because it is running RIP and OSPF. It's not RIP and OSPF. So we've created RIP to OSPF, and now we are creating OSPF to RIP. And then I will just set the tag. The tag will be, the tag is always on OSPF routes is 110. So if you go to R15, for example, and say show IP route, OSPF always has 110 administrative distance of 110. This side here, it is called administrative distance, and here is called the metric of the route. So the administrative distance of the routing protocol and the metric of the route in here. So that's what it is. So I'm going to I said it just 110, which is the administrative distance of OSPF. Okay, now I'm gonna write another route map, and that route map I will call RIP to. It's just the same. It's just the one we said, RIP to OSPF. RIP to OSPF, yeah. That RIP to OSPF we already created here. I'm just putting it back. RIP to OSPF we created here. So what I'm going to do, I will just deny match. I will just say match. Sorry. Okay. So let me just delete this guy because I messed it up. So now let me just do show run route map, because I'm gonna recreate that route map. Yep. Wow, we don't know. That was a previous route map. So now this is the only one we created now, OSPF to RIP, and then I said match tag 10. So now I'm going to go back and say RIP to OSPF. RIP to OSPF, and it said set tag 120, because RIP route is always the RIP administrative distance is 120. And then if I go back and say do show route map, I have two route maps on R2 now. So I'm sorry, on R3. So one is OSPF to RIP permit 10. So that means I permit this OSPF permit that OSPF routers to have a tag of 120 or 110, and permit roadmap RIP to OSPF permit so that RIP routers will have 120, which is their administrative distance. And now I'm just going to take an create another roadmap, which is RIP to OSPF, but at this time I'm going to deny. I am going to deny 20. So this is just a sequence number, yeah. I'm going to deny 20. So what am I going to deny? I will say like match tag, because I'm going to deny because we are in the RIP, right? We are in RIP routers, right? So I'm going to deny OSPF because we are in the RIP to OSPF. So I don't want OSPF to come back to RIP, so I'm going to deny the OSPF tag that I gave in here. Then I am going to create another one here, OSPF to RIP at this point, and then I'm going to deny, sorry, before I do that, then this one I will permit 30. So that means like this route map RIP to, now I created OSPF route map RIP to OSPF, and then I denied, and then just a sequence number, but I said match tag 10. So the match tag 10 is this one, because we gave OSPF routers their administrative distance number, but you can give any number. It's just the identification number. I just want to match. I just like to match the OSPF the administrative distance. So I said, since I set this number to OSPF routes, that would come back to RIP, because I don't want this come back to RIP. This route is because if this route is OSPF went to RIP, If they come back to OSPF, then it's going to be a problem. That's what is causing loop. So I am asking them not to come back. That's what I'm denying. When they were back, now they are going to RIP. So if they are coming from RIP and coming back to OSPF in the future, I'm just saying, please deny. Just the roadmap has just the same name. The name doesn't matter. I just gave it the same name, RIP to OSPF, but I said, please deny, and then the sequence number, and then I said match tag 10, and then permit any, and then roadmap, then RIP to OSPF, and then permit 30. Okay, now I'm going to permit an OSPF 1 now. So I am asking now, I'm saying now, roadmap, RIP, what do you call it? Yeah, so I already, I'm going to, now I'm saying roadmap OSPF to RIP, then this time I'm going to deny, that deny just a sequence of 10, then I'm going to match the RIP routers, which is 120. Match tag 120. So this time I'm denying any routes, any OSPF routes that would come back to RIP. Any RIP routes that would come back to OSPF. So now, if we go to all the way to the end and say show run, so I will show you what we have created. Show run roadmap. Then this is what we have created. We have created the first roadmap. We said roadmap OSPF to RIP, and we said permit, but what we said like roadmap OSPF to RIP. That means like OSPF route is going to RIP, permit, but set the tag, set identification number of 110. Those will be OSPF routes. And here we created another roadmap. We said roadmap OSPF routes that's going to RIP, OSPF to RIP, then deny. I said deny 20. So we denied, and then with the sequence number of 20, because this one sequence number was 10. And then I said match tag to 120. That means like any route, any RIP routes that is coming back to OSPF, please deny. So they have this tag 10. Any routes that is going, any OSPF routes that is coming back from OSPF to RIP, please deny. So because the identification number will be this one, so if they match this number, then they will be denied. And then we create another roadmap, RIP to OSPF, and then we said permit. Now it's a RIP routes, so we set them to 120. So the 120 is the norm. The RIP routes will have 120, and this is the administrative distance. So I just like to match, but it doesn't need to match. It could be any number. This number is just the identification number. So you just set in the tag. The tag is the identification, for example, identification number, and this is the identification number. And then we created another RIP to OSPF roadmap, and we said deny, and the sequence number is 20. And then what we said here, we said deny match, which is deny, is a deny statement right here, and then we said match tag 120, 110. So what is the 110? 110 is the OSPF and routes, and then we said permit route map RIP to OSPF permit 30, and now I need to permit another route map here, RIP to OSPF permit 30. So now we have to permit. So this is what we have created so far. Route map OSPF to RIP permit 10, set tag 110, which is OSPF routes, and then we say route map OSPF to RIP again, and then we said deny, and the deny we're gonna deny any RIP routes that's coming into OSPF, coming back into OSPF, and then we say route map OSPF to RIP, and then we give the OSPF routes, and then we said like a route map OSPF to RIP permit 30, and then we create another route map here, route map RIP to OSPF, and then we permit 10, and then we said a set means like give the tag of 120 any RIP routes, and then we went here OSPF RIP to OSPF, and then we deny the statement, and then we said please match, which is deny any RIP route that is coming back into OSPF, and then we say route map RIP to OSPF, and then we say permit 0. So what we're gonna do now, I'm gonna copy. Now I'm gonna go to Notepad. I'm gonna modify. So if I go here now, R1, R3 in this way is R3. So R3 statement. Okay, so now if you go to R3, so we're gonna apply. How are we going to apply? So I'm just gonna deny. So how am I going to apply? So the way I will go, I will apply. I will go to router and OSPF, for example, 1, and then I'll say redistribute. Now let me just do show run section router, and then I will go to router OSPF. Then I will say router, redistribute RIP subnets, and then the subnets, the route map I will choose it will be the route map I will choose it will be against 1. So I will take the name of OSPF to RIP. So the route map will be OSPF to RIP, and then I will go to RIP routes, and then I will go to redistribute, and then I will say route map, and this route map will be, because now you see this was a RIP route, but I said here OSPF, so that is exactly OSPF to RIP. So if you use the route map which is RIP to OSPF, and if you say like, okay, I'm redistributing RIP, so I will just take RIP to OSPF route map name, and you apply that route map here, it's not going to work. So they always the opposite. Now I say redistribute RIP subnets, and then the route map I chose is the route map that is denying 120. That is denying 120 OSPF route. So that it will deny it is denying 120, and it is a OSPF to RIP. So if you when you say redistribute and you wanna apply the route map must be on the other side, on the opposite side. So it's not, don't take it like RIP to OSPF in the here, because don't say like, no, I'm seeing RIP here, so I'm gonna put it RIP here. It's just exactly the opposite. And now redistribute OSPF metric, and then I will put it the RIP one. So what is the RIP? This RIP is denying. This RIP is denying. You see, it's just the same. Anyway, the name is the same, but it's denying. RIP to OSPF is denying OSPF tag 10. So roadmap is OSPF tag 10. So we've done R1. So we've done R2. Sorry, R4, and in R5 and R1. What I said R4. What I'm going to do now, I am just going to modify this guy right here. So what I will do, I'll just copy, and then I give, and then we'll say R4, and then so now instead of R, this guy is running. Sorry, this guy is running is RIP to EIGRB, isn't it? So we're going to take off OSPF, and then we're going to say EIGRB to RIP. EIGRB to RIB, and then we are going to say 90 because EIGRB tag is EIGRB tag for the administrative distance I'm going to match is 90. So now I'm going to say EIGRB to RIB deny 20, but what are they going to deny? They will be denying, yeah, they will deny exactly, this is the same because it will deny 120. So it will allow EIGRB to RIB set tag 10, and then this match statement is a deny statement, and it says match tag 120, and the permit 0 is EIGRB to OSPF. So EIGRB to OSPF permit 30. So the second one is OSPF EIGRB we are just modifying EIGRB RIB to EIGRB and then permit, and then the RIB route is we are going to set 120, which is good, but here we're gonna deny 90, and the permit RIB to EIGRB okay, RIB to EIGRB, you see, and now we are good to go because we went to EIGRB, we give them EIGRB to RIB, we give them a 90, which matches the internal EIGRB routes, and then we set a route map EIGRB to RIB deny 120, that's a RIB route, and then we permitted 30. I mean, like any other route, 30 is just a sequence number, it can be any number. And then we said route map, this is the second route map, RIB to EIGRB, and then we said permit, and then we set RIB routes to 120, and we went again RIB to EIGRB, then we said deny, and then we said deny EIGRB route to come back and then permit. So I am going to get this guy, copy, and then go to R4 and then create first. Then I will go show run section router, and now I am going to go to EIGRB, and then we take it to redistribute RIB metric, and then we say route map, and the route map will be exactly as I said, exactly the opposite. So now we are redistributing RIB, but what you are taking is EIGRB to RIB, because EIGRB to RIB, what is it doing? It is denying a tag to 120. And then we are going to RIB, and you take it and then you redistribute. I'm just making it easy, so I'm just copying and pasting here, and then the route map will be here. We see RIB, EIGRB, and then we must take RIB to EIGRB because it is denying EIGRB routes to come back to EIGRB. RIB route is to come back to EIGRB, and now this one is done as well. Okay, let me go to R6. Let me just go to my notepad and modify again. So let me just minimize this. So now I'm gonna copy this because I just want to not this one. This one is just close because we have OSPF there. Then I'm gonna go here. And then I'm gonna paste. So now I'm gonna modify. So R6 is running OSPF and EIGRB. So what we are going to say here, let me just say R6. So now I'm going to modify a little bit. So now we say like route map OSPF to EIGRB. To EIGRB. And then we're going to give permit set tag 10, which is good. And then we can say OSPF to EIGRB. and then we're just gonna deny 90 because we just modified. So we say route map 30 is okay. So create another route map which is OSPF, which is EIGRB. Say EIGRB OSPF, and then we're gonna see give it 90. Then we are going to EIGRB to OSPF, and then we're gonna deny 10, and then we are going route map to OSPF and permit, and then we have modified. So let me go to R5, sorry, to R6, then show run section router, and then I'm going to go to router EIGRB. Okay, before I do that, let me paste the routes commands. Yep. So now do show run router. Then now I'm going to go to EIGRB and then say redistribute. That redistribute the route map we're going to take it is just exactly the opposite. So OSPF to EIGRB. EIGRB to OSPF, because now we say redistribute OSPF and then we take in the opposite because it's the 910. That's good. And then we are going to OSPF1 now. Then we taking this redistribute right here, and then we are taking with once we see EIGRB, we are going to take OSPF, which is the 9, which is the 9 tag 20, OSPF to EIGRB. OSPF, oh sorry, route map OSPF to EIGRB. And now, my friends, the problem has been solved. Before you have seen all this loop here, but now the problem must be solved. So now if I go to, I'm just hoping it has been solved. So now if I go to R6, because before the loop we had was 10 10 10 to trace 10 10 10. So now if we trace that 10 10 10 here, what's gonna happen? Let me check it. Now we still have it, but we say like clear IP route, but it still has it. Yeah, because of the JNS3 bug. So what we're gonna do now, what we're gonna do, we are going to save these routes, and then so now show route map. We have all the route maps right here, and then we go to route map right here, show route map. We have the route map. Okay, and R3 show R6 show route map, show route map. Okay, good. So now it still has it. What we're gonna do, we're gonna turn it off and turn it back on, and then it should work. Because of the JNS3 has a bug, and just keep taking all the, so now sometimes, I mean, it is just a new thing for me, and I just solve using this problem sometimes, So now everything is going to be done just right in front of your eyes. That's what I'm going to do. So if you are successful now, that is how you will use a route tagging method to prevent. That's how you will be using to use route tag. And this one, I'll just save it and I will send it to you later on. I will just put it into the course assignment, so you can see the feel of it, if this works. Because the adjacency has not come up yet, so they just started, so it's just normal. Show run. Okay. Why? Show IP, OSPF, neighbors. Okay, cool. Oh, we still have the okay. I think something is wrong with our loop, with our thing. So we're gonna work on it. So it's gonna be okay soon. So give me a sec. So let me check it and review what is wrong with our roadmap. What is wrong with our roadmap? Okay, so our roadmap here says we're OSPF to RIB, صح? And then we set it to 100, 110, hey? OSPF to RIB, deny 120. The OSPF to RIB permit 30. That was good. The roadmap OSPF RIB to OSPF, and then set tag 10. Then OSPF RIB to OSPF, roadmap OSPF RIB to OSPF, and then match tag 10, and then permit 0. And here we have a roadmap EIGRB to RIB, and the roadmap EIGRB to RIB, deny EIGRB, deny 120, EIGRB, and then EIGRB RIB to EIGRB, and then roadmap RIB to EIGRB, RIB to EIGRB 120, and then we denied 90, and then we said permit. Perfect. Okay, so if I take another one, gonna that. Well, let me just, I'm just comparing the two our roadmap is right here that I made it. So you know, these are just some really. So in here, in R3, we say RIP to OSPF, and then we said RIP to OSPF, yeah, RIP to OSPF, and then we said 120, and then we said RIP to OSPF, and then we denied one tag, and then we said permits 30, good, and then we said RIP to OSPF to RIP, OSPF to RIP, said OSPF to RIP, OSPF to RIP, and we said tag 110, good, and then we said RIP to OSPF, then match 120. So that is good. Set tag 20. We said okay, let us go back. RIP to OSPF. What is the RIP to OSPF? Or RIP to OSPF? We said set 120, set 120. Match tag 10. We said match tag 10, the deny statement right here, and then permit. That's okay. And then we said OSPF to RIP, we said set tag 110. So that then we said route map OSPF to RIP, and then we said deny 120, which is deny 120, which is very good. And then we said permit 0. That is R2 is identical, R3 is identical. Okay, if we go to R4 in this case, where is R4? R4 is here. Okay, R4 we said EIGRB to RIP, we set 90, right here is the same, and then we deny statement is 120, then permit 30, very good. And then we said route map RIP to EIGRB, set 120, that we said 90, we said 120, and then match deny 90, and then route map is 120. Okay, and then we said router 4, router 5, what is it? Router 6. We said OSPF EIGRB to OSPF, set tag 90, and then we said route map EIGRB to OSPF, deny 110, and then permit. And then we said EIGRB or OSPF to EIGRP, SASA 10, deny. So I think the only problem is just the GNS tree. So let me get it off. Give a sec, and then we're gonna restart again. So let it shut down. And then we're gonna start it again. So it's gonna be just it's gonna give a sec. So now let me just goes to our routing redistribution right here. It's just okay, they're all fine. So I created both. Redistribution .txt. redistribution for CCIERS V5. Yeah, let me just write V5, and then so now they should work. So now everything seems fine here. Sorry guys, it took a long, but I just want to make sure that you get it. This is overkilling. These are overkilling, so we are doing I'm trying to do my best so you guys understand. Okay, let me just go back and I'd say, okay, let me just go here and R3. What I have done, so we say redistribute redistribution roadmap of RIP to OSPF, OSPF to RIP, good, and then OSPF RIP to OSPF. Perfect. And then what about R4? What do you have said? R4 RIP to EIGRB to OSPF and roadmap RIP to EIGRB under EIGR. Good. What about R6? Should run router, and this one now is redistribute on R6. Yep, redistribute roadmap EIGRB to OSPF, and then route map OSPF to EIGRB. Absolutely perfect. So at this point of time, let me check on R3 if we have that number. Show IP route RIP. Do you have 10? Yep. It's a 10.1. Cannot ping it 10. It should have ping 10. And R1 is just advertising, isn't it? No auto summary. I think let me go to R3. Okay, can you ping 10.2.1? Oh, you can't. Okay, trace route. Still there is a loop, so I'll do it. I'll deal with it. Hello guys. I think there was some other issue right here. So but now we have reachability all across. So if we say trace route 10.1.1.1.1, then we are okay. So the problem that we had was this guy had authentication, this link, and this link had partial authentication. For example, he had a keychain on this interface, and this had a like RIP authentication, and this interface didn't have it. So we had all those sort of problems. But in route tagging wise, to prevent the loop, as you can see before, it was so that was the problem that we were facing. But before, where was it? But before we had a route tag, I mean sorry loop here. But now, yeah, you see, as you can see, when we try to trace route, then we had all this big loop. But now we're all set. If we select a trace, then it goes to R7, then to R3. So this network we are targeting is that one, right? So now if I'm on R6, I trace route, so it's going to 67, which is here, 67.7, then 37.7, which is right here, this interface, and then it goes 23.2, which is right there, and then 12.1, which is right here. So we are all set, and I hope it has been informative for you. I know it is a really long, but I didn't want to catch. I only stopped one time, and that is the time I was just checking the links in here, and I had no other problems at all. Let me show you the problem that we had. I removed it over. You see, we had let me show you here. The problem is that where is it? On R3, no, on R3 it didn't have anything. On R2 we had authentication. So look, I just removed the authentication on R2, and R2 interface just gigabyte 1/0, as you can see, 1/gigabyte interface gigabyte 1/0, and then there was authentication. So I said no authentication, no IP RIP authentication, no IP RIP authentication MD5, and no IP RIP authentication, a keychain, and then I made that keychain as Ali. So I removed. That was the problem that we were having, that we didn't have reachability. But now everything else has been sorted out, because we would have a loop if we did not work, if we did not configure our redistribution. So show run section route map. That is what stopped us from having a route map. So I hope it has been informative for you, and this is the last lap of redistribution, and I hope you enjoyed, and you just try yourself, and I will definitely send you the configuration PDF, what they call like notepad text, in a notepad text. So hopefully enjoy and try yourself, and see you on other course. Thank you.